Every second of every single day, our home planet is bombarded by an immense glowing wall of solar energy. But because Earth is a sphere, this energy is distributed incredibly unfairly. The curvature means the middle of the planet takes a direct hit, roasting our subtropical zones into scorching deserts. Meanwhile, the extreme upper and lower latitudes receive almost zero direct energy, leaving the poles locked in a deep, perpetual freeze. Logically, if this dynamic were left unchecked, the equator would continually absorb heat until the oceans boiled, and the poles would freeze solid. Our world survives because it isn't a static rock. It operates as a massive, active thermal engine, constantly working to balance its own extremes. The energy actually reaching us is called insolation, incoming solar radiation. Earth only intercepts a microscopic fraction of the sun's total output. This model shows why insolation hits unevenly. Due to its axial tilt, solar rays strike the equator directly, but hit poles at a glancing angle. These slanting rays travel through a thicker atmospheric slice, losing much energy to scattering and diffusion. Earth does move slightly closer and further from the sun throughout the year at its aphelion and perihelion, but this variation plays only a minor role in our daily weather. The true driver of our climate is that permanent geometric inequality. That spatial imbalance of heat is the exact fuel powering the global engine. Earth's heat budget starts with 100 units of incoming solar energy. 35 units bounce off clouds back to space, our albedo. The remaining 65 split. 14 are absorbed by the atmosphere, leaving 51 to heat the surface. To prevent oceans from boiling, Earth sheds this exact 51. Greenhouse gases catch this, heating the atmosphere, before the energy escapes to space, balancing the budget at 65 units returned. The global ledger balances. But it doesn't solve the local crisis of a roasting equator and freezing poles. To survive, the Earth is forced to physically move that massive surplus of heat from the tropics toward the high latitudes. It uses convection, a vertical transfer of heat that pushes warm surface air high up into the troposphere. We experience this vertical heat transfer on the ground as massive, towering thunderstorm systems. But the horizontal transfer of heat, known as advection, is far more significant for driving our daily weather variations. The human impact of advection is severe. In northern India during summer, this horizontal heat transfer creates the Lu, a blisteringly hot, dry wind. Every breeze you feel, every ocean current, and every severe storm is simply the planetary engine struggling to redistribute its thermal budget. What happens when local topography breaks the thermostat and the thermal engine stalls? You get an inversion of temperature. This is a dangerous reversal of the normal lapse rate, where the air actually gets warmer as altitude increases. It happens during long, clear winter nights. The ground rapidly cools, freezing the air immediately above it, while trapping a dense lid of warmer air higher up. For megacities like Beijing, the consequences are deadly. Smoke and dust get permanently pinned down under this warm lid, suffocating the city in smog. These massive pollution events are direct symptoms of a localized failure in Earth's heat distribution system. Our ability to breathe clean air and our very survival exists strictly within the narrow, fragile margins of Earth's heat budget operating correctly. Let's run a quick audit to see if you understand the mechanics of the planetary engine. 3 rapid-fire questions. Question 1. What percentage of incoming solar radiation is reflected back to space before reaching the surface? Question 2. The transfer of heat through the horizontal movement of air is known as what? Question 3. Earth radiates energy back to the atmosphere in what specific form? Answer 1. 35%. Earth's albedo. Answer 2. Advection. Answer 3. Long-wave terrestrial radiation. Hit the comments and post your score to prove you understand the invisible forces keeping our planet alive.